Hello, so I'm Jordan Siegel, the captain of Suffern Robotics, and today we're going to be talking about how to master the mechanical aspect of your team. So this just involves everything like physically building your robot. If you have any questions, you could feel free to email outreach@suffernrobotics.org, or you can reach us on social media at Suffern Robotics. So just a quick introduction to our team. So we've been a team for over 15 years, and in those years, we've been to the World Championships 5 times. And so far in this season, we have won the Design Award and came in second place for the Inspire Award and have advanced to our regional championships. And last season, we also advanced to our regional championships by winning the Think Award and coming in second place for the Inspire Award. And so we kind of know what we're doing a bit. So first, I'm just going to talk about the importance of mechanical and just everything it provides for your team, because it has a lot of benefits that you might not realize. So the most obvious is that it allows you to have a working robot. Mechanical, as I said earlier, involves all physical elements involved in building and assembling a working robot. So having a strong mechanical team and a strong mechanical force allows you to have a working robot, which is kind of one of the most important parts of robotics. And it's also necessary for all aspects of a competition. While you could technically still advance without having a working robot through awards, having a robot that works, or at least attempts to work, is super important to judges because it at least shows you're making an effort. And I mean, it's robotics, so it's nice to have a robot. And it's also, we're a robotics team, so building a working robot is what a lot of people come for. So doing that is super impressive and stuff, and is also a goal for many of your team members. So another important thing that mechanical leads to is winning competitions. As you guys probably know, competitions aren't solely about having a good robot, but in order to win the top awards, a good robot is often needed. And additionally, having a strong robot allows your team to increase your chances of advancement by allowing your team to perform better in matches. Well, there's a lot of variables that go into match play, such as your teammates and if anything breaks or Wi-Fi issues, etc. Having a good robot just increases your chances for things to go well. And even if stuff goes wrong and you don't get to pick and you're not an alliance captain, having a good robot will still increases your chances of being picked for an alliance team, a final alliance team. And one of the most important parts, at least for our team, is sponsorships. While many sponsors might not know specific details about robots and first, they do know what to look for. And so having a good robot, even if it just means it's able to move around quickly and it's able to pick up blocks or whatever and do a fun demonstration, many sponsors find that to be super engaging, and they like seeing that you're making physical progress and are actually building a robot. Um, and while, again, some sponsors might not need or want to see it, it could still be a huge selling point, and it could lead to um, outreach events, even where you're meeting with sponsors and saying, hey, thank you so much for your sponsorship. Here's how your money or goods or mentorship have helped us build this robot. So it's really important for sponsorships as well. And as I mentioned a bit earlier, outreach events. Now that COVID is starting to die down a bit, community events are starting to come back up, and having a good working robot is super important for these kind of events. Many people find seeing a robot impressive, even if it doesn't necessarily work. They just like seeing a robot, and it kind of just shows, yeah, we're able to build this. And If you feel comfortable allowing kids and even sometimes adults to drive your robot is super fun. A lot of times they love it and it's really engaging. And this is just a great way to connect with your community, to advertise your team, and you can even collect donations and stuff like that. So having a good robot is important for more than just the competition. And finally, one of the, in my opinion, most important parts of focusing on mechanical is that it helps you prepare for the future. So working mechanically and just with building stuff is super important for many jobs in the future. And even if you aren't going to go into something mechanical, it's also just super good to know how to be able to repair stuff just for around the house and just in general. So it's super good. And additionally, um, it also helps to keep your team sustained. Mechanical, as I've mentioned, is one of the most important parts of a team. And so having new members and um, just everyone really work on mechanical, you're helping to ensure that your team is able to be sustained for years to come. And so it's really important. And now I'm just going to talk about the mechanical process because it can seem a little overwhelming. I mean, it's pretty much everything to do with building, so it's a lot, but I'm going to try to break it down. So our team uses the engineering design process when just building our robot. So it's used mainly when just trying to solve any problem. As you guys can see, it's like a circle, and I'll kind of get into that a bit more later, but it just pretty much provides the steps of how to go through and solve a problem. And so I'm just going to break down how we do that. So first step is brainstorming, and I'm sure a lot of you guys do this already. So the first part is to just brainstorm different possible solutions. So our team likes to do this by getting around a whiteboard and just sketching out different ideas we might have. And one of the other things we also do during this kind of phase in our design process is to discuss different priorities for our season. So, for example, this year we talked about whether or not we wanted to go over the barrier or around the barrier. In prior seasons, we talked about what type of wheels we wanted to use. So, this is just really kind of setting up the building blocks for your season and ensuring that you have a good foundation and good kind of basis for all your ideas. And brainstorming is one of those things that kind of happens as you go, but having like a good solid brainstorming session with your entire team at the beginning of the season allows everyone to be on the same page for your general kind of ideas going forward. Next is prototyping. So after brainstorming, we like to make prototypes of some of our ideas. And prototypes are just kind of quickly built versions of our designs so we could test ideas without having to spend a lot of time or use a lot of materials to actually test these ideas. This allows us to just, again, test ideas to make sure they work the way we want to before we spend months and lots of time and materials on an idea and then have it actually not work. Again, prototyping is one of those things we kind of do a lot throughout the season. So as our ideas fluctuate, we'll often build a quick prototype to test new versions and make sure it works the way we want it to. After prototyping and kind of coming up with our favorite concepts, we like to use a 3D modeling program in order to design our robot beforehand. We use Fusion 360, but there's also many other programs out there. Like I know teams who use SolidWorks. I know some teams who use Blender. So it's really just about finding what software works best for you. We like Fusion because it is cloud-based, and we're also able to get free accounts just because we're students. But again, it's just about finding what software works best for you. So, using a 3D modeling program, this ensures that our entire robot will basically be able to do what we want it to do, and we won't have to struggle to fit stuff in later or have stuff that doesn't fit. and it allows us basically to ensure that everything we want will be on the robot. Um, and it also is really nice because it's kind of like instructions for when building your robot. It's like using like a Lego guide because you're just copying what you see, what has already been made. And it's also good because it helps to provide documentation for future years. So there's been many times where there's a design that we've used in the past few years, and we're able to just go back and look at it and be able to alter it to fit our design. It helps you to avoid reinventing the wheels. And again, it's just something that's good for maintaining your team's legacy. So after fully designing our robot in CAD, we begin to fabricate or basically build the parts we need for our robot. So this is pretty much done if your team decides to use custom parts for your robot. So we like to use custom parts because it allows us to do stuff with that might not be available otherwise. I'll talk about that a bit more detail, but we make these pieces typically out of metal, and we use just common hand tools such as a bandsaw or a drill press in order to get the desired shape and sizes. After the completion of our individual components through fabrication and just purchasing parts, we begin combining everything together into different subassemblies and then larger subassemblies. Working in smaller subassemblies has been super helpful for our team because it allows us to kind of have different people working congruently, and then we could just combine everything at the end. So this allows us to maximize our time. And it's also helpful because if, let's just say, one part of your robot doesn't work or part of it breaks, you don't have to disassemble the entire thing. You could just take off that one part that doesn't work. So, and then we also do assembly at kind of the same time. So we'll have someone working on the chassis, and then once someone finishes, like let's just say the intake, they'll put it on the chassis while someone is still working on the output. So this kind of helps us be super efficient and again is really useful. So after completing different parts of our robot or the entire robot, we like to test things along the way just to make sure everything works the way we want it to. Um, Testing along the way just allows us right then and there to know if our idea needs to be improved. This way, again, as I mentioned earlier, you're not sitting there with a completed robot that doesn't work and you have to figure out, go back and kind of redesign everything. And also, testing along the way allows us to look at these parts and see, hey, is there anything we could change quickly to make it work, or do we have to fix this entire idea? So, again, this is just a way to be efficient and ensure that later down the line, things work the way you want it to. And then, as I mentioned earlier, all of we just kind of repeat the process. So, a large portion of the design process is just repetition in order to get the best possible results. So even if the robot is finished, there are often things that could still be optimized. And even if there isn't something obvious or something possible that you could do to make your robot better, there's still stuff you could do, such as practice with autonomous and driver practice. So there's no real end for robotics, and I'm sure some of you guys already know that, but that's just something to keep in mind. And now, as I mentioned earlier, there's a lot of different methods to building and fabrication, and it could be a little overwhelming, so I'm going to try to break them down. So, while not necessarily building, 3D printing is super important, and a lot of teams utilize it. So, sometimes it could be easier to design a specific part in CAD that could be 3D printed to accomplish a specific task that a part might not be sold for. So, for example, our team needed these super specific brackets that weren't really in any size. And so instead of trying to make brackets ourselves out of metal and stuff, we just made them with our 3D printer. And this allows us to, again, accomplish a task that we wouldn't have been able to solve otherwise. And if you're designing your robot in CAD, or at least parts of it on CAD, It's a lot easier to make 3D printed parts just because you can design them directly on your CAD assemblies. And I know 3D printers are kind of expensive. So if your team doesn't have one, there are many companies that are able to 3D print, and you can even talk to some local companies and see if they'd be willing to sponsor you or give you a discount because you're a robotics team. A lot of times companies are willing to do that if they know that their products are going to go on the robot. Um, but in general, I would recommend if your team has some money or just saving up for a 3D printer because it is extremely useful. Next, as I mentioned earlier, fabrication. So this is a way just to build custom parts for your robot with tools and other materials that are often readily available. Our team uses metal and just other like hand tools such as a bandsaw. We use a sander and stuff like that. So, like with 3D printing, this allows your team to have access to parts that are probably not sold on the market, or if they are, um, this just allows your team to kind of have customization of them to complete a specific purpose. So we've made certain panels that wouldn't otherwise be available. And so even if you are using a build kit, which I will get into earlier, fabrication is crucial to ensuring that your robot is able to complete the tasks you want it to. Next is CNCing or machining. So, like the other options mentioned before, using a CNC allows your team to create custom parts otherwise not available. So for those of you who may not know, a CNC is kind of what I like to call a reverse 3D printer. So a 3D printer works by building up plastic layer by layer to get the end design. A CNC works the opposite. So you start with a piece of metal and then cut away in order to get your final result. So CNCs can be very expensive and require a lot of training in order to use them. So if your team wants to use custom metal parts, as you can see in the image there, or like in the past, our team has made custom chassis, you could use a CNC and try to save up for one, or there are often many companies that will offer CNC or laser machining as a service. And again, similar to 3D printing, if you mention that you're a robotics team and say, hey, this would be our robot, they'll oftentimes maybe give you a sponsorship or a discount. So CNCing is definitely something that is super awesome if you're able to do it, but also if you can't, don't worry about it. I just wanted to cover it just in case people were curious. So now pre-built kits. Most teams are probably familiar with these. So these are kits which come with pre-made channels and other parts with holes that all kind of fit together that allow you to arrange them however you want in order to create kind of a basic frame, chassis, etc. It's kind of similar to like Lego, if that makes sense. These kits are extremely useful for both rookie and veteran teams. For rookie teams, when you don't have a lot of material starting out, this provides a solid foundation and allows you to kind of use limited resources to build a great robot. And for veteran teams, it's just useful to have these parts lying around to attach to stuff you might already be making. So there are many different build kits out there, and it's important to figure out which one would work best for your team. So Tetrix, which is considered one of the oldest build kits around, Tetrix is primarily uses metric, but it could also be used with some imperial parts if sized correctly and using proper conversions. It also doesn't contain a lot of holes, which can be kind of constricting when building. Um, if you want to alter your design later, you might not have the hole available to do what you would like, so you're either going to have to drill it or figure out placement. So that's definitely a negative thing. But for all our older veteran teams, a lot of us have a lot of Tetrix just lying around because, as I said, it is one of the older build kits. So if you already have it around, it's definitely worth using, especially if you don't have the money to invest in a newer build kit. Next is Actobotics, which is a kit made by Servo City, and this is designed primarily for FTC. Ectobotics is Imperial, which can be pretty difficult to, and it is pretty difficult to use any metric parts with it at all, which kind of is annoying because our team primarily uses metric, but it's up to you. As you guys can see, it has a lot more holes than Tetrix, so that makes it more useful right off the bat. And it also has been around for a bit longer than other newer build systems, but it's a bit newer than Tetrix. So, like Tetrix, we also just have a lot of Actobots lying around. So for veteran teams, again, if you have it, I would recommend using it, especially if you can't afford a newer build system. Next is GoBuilda, which is personally my recommendation, but I'll get a bit more into that later. So GoBuilda is a newer build system. I think it came out a few years ago, which is also made by Servo City, similar to Actobotics, which is Servo City. And it's designed entirely for FTC. The system uses metric, and there are some conversions available to Imperial. Since it's newer, it offers a much sleeker design, and it has, again, many holes, and it has just really good features, especially for FTC teams, where you can place motors inside the channels. That's my personal favorite, to help save space. And it's just overall a much sleeker design. However, like I said, it is newer, so for veteran teams who might have other parts, it's not necessarily worth it to buy this. But if you are a newer team, I would recommend it. Now, which is best for you? There's no correct answer. It really depends on the team. For veteran teams who may have a lot of Actobotics and Tetrix lying around, switching to a build system can be expensive, and it's also difficult because you might need to purchase new tools and new screws, and there's just a lot that goes into switching to a new build system that you might not realize. Our team recently switched to GoBuilda, and along the way there's a lot of stuff that you don't consider, like pieces that you might forget to order, and now you're having to wait a week to get in a new piece that you needed that you forgot to order. So for veteran teams, if you have a lot of Tetrix or you have a lot of Actobotics and you're familiar with it and you're able to make it work, I would recommend maybe just sticking with it, unless there's something really specific you want from a newer system, in which case then you could switch. But for teams, Tetrix is able to do the job, Actobotics is able to do the job, so it's really up to you. However, for newer teams, I would recommend going straight to GoBuilda. It is a little expensive, however, I think it's worth it. It's super sleek, and it's just able to accomplish a lot of things that Tetrix and Actobotics can't. And so if you're looking for a new build system to buy right off the bat, GoBuilda is great. And they also provide discounts for FTC teams. So I would recommend that. Next, I'm going to kind of go into managing mechanical. So mechanical is a large part of the team and often has some of the most members dedicated to it. So it's important to know how to manage it properly so things don't get out of control. So this is how our team likes to manage mechanical. So at the top, we have kind of our team captain who manages everything, including mechanical, but isn't directly involved. And then under them, we have our head of fabrication and head of machining. Our head of fabrication kind of manages all the building and assembling parts. So if we're building a custom part, they'll help manage that, or just kind of assembling the robot. They're kind of in charge of that. And our head of machining, on the other hand, focuses more on CNC and that kind of thing. So this isn't necessary if you don't have a CNC or plan on using that or building any custom metal parts. However, our team does have one, so having that is useful. And then these people are in charge of all team members, more specifically all mechanical team members, who kind of report back directly to them, and if they have any questions or issues, stuff like that. So having different steps along the way is really useful because it allows kind of there to be different checks and balances and to make sure that everything gets done, and if there's questions, they get answered. And it ensures that the team is working fluidly and stuff is getting done the way it's supposed to be getting done. Now, our team uses Google Sheets in order to keep track of what everyone on the team does in a day. So if you kind of see, we have the date, and then we have room for the people to write their name and then what they have done. So this allows us to know what a particular person has done on one day, if they finished, what needs to be done, and if there's any photos associated with what they did. This allows us to know what we need to work on future meetings, and it's also super useful when it comes to documentation. And now, team management software. Our team in the past has used team management software, but because we are a school team, we're no longer allowed to use it. But it could be extremely helpful. So there are many free options available, such as Asana, Trello, Monday.com, etc. These are all very useful because it allows the team to keep track of what needs to be done, what has been done, and it allows you to sort into different categories. So you could have sections on mechanical, you could have sections for CAD, and it's really useful and allows you to see visually what needs to be done. So I'm just going to kind of go over some mechanical tricks we've learned throughout the years. Mechanical can seem like a very overwhelming concept, and it is because it encompasses a lot, but there are many different tricks and tips that we've learned throughout the years that make the process a bit easier. So at the start of our season, we've done workshops, which allow us to kind of ensure that newer members are starting with a baseline level of knowledge. So at the beginning of our season, we spend about a week doing workshops in the 4 main areas of robotics: documentation, CAD programming, and of course, fabrication. So we have all of our new members practice with using basic tools, so cutting different parts out of metal, using the bandsaw, or drilling holes using their drill press. And then we also have them make basic H channels using H chassis using GoBuilda channels. So this allows them to kind of have practice with some of the things we're doing most with mechanical, which is just making parts and building chassis. So once we start prototyping, this is extremely helpful because it allows kind of everyone to have a baseline level of knowledge in the workshop and allow them to kind of feel more confident when it comes to building. During our workshop for fabrication, we also spend time going over workplace safety. So this is extremely important for any mechanical organization as well as a robotics team, sorry. It just makes sure that everyone knows how to be safe and ensures that there's no accidents later down the line. So we went over basic safety information, such as how to properly operate tools, where to find different safety equipment, such as our safety goggles and first aid kits, and just how to be safe in the workshop. So going over this right off the bat allows us to ensure we're safe throughout the year and that there's no major accidents. Another thing we do to help keep our mechanical going strong is we like to do certain cleaning and organization days. So in order to keep our workshop organized and reduce the time we have to spend looking for tools and different parts, we'll regularly have days where we spend time cleaning and organizing the workshop. So we won't have days where everyone just stops what they're doing and organize. We'll have certain members take a break from whatever they're working on and spend some time, not even an entire day, but just making sure that everything is in the right spot and help organize any loose materials and just ensure that everything is easy to find. Again, this just helps improve efficiency because there's been times where we lose a drill bit or we lose a part, and then we have to kind of have everyone on the team like, okay, everyone please spend 5 minutes looking for this. When instead of doing that, just along the way, you could take small breaks and just have team members organize stuff as you go along. Now, as I mentioned a few times, mechanical is one of the largest parts and most important parts of any robotics team, so it's really important that everyone gets involved, even if they're not builders. So I'm just going to go over how we do that. So, again, at the beginning of the year, we did workshops. This ensures that everyone has a basic understanding of mechanical concepts. And what we'll also do sometimes is before competitions, we'll kind of say, hey, everyone take a break from what you're doing, and we're going to go build this part, we're going to do kind of uh, an assembly line. So certain people will work just on drilling holes, other people will work just on using bandsaws, etc. And so everyone having that kind of basic understanding of mechanical concepts is super crucial to that. Additionally, during competitions, we assign certain people to just focus on repairing the robot between matches or adding stuff. So these people will go, they'll watch the matches, and then something goes wrong, or a part breaks, or we just need to add something, etc. Will They'll be prepared, they'll grab the tools necessary, and once the match is over, they'll start working. It's kind of like a NASCAR pit crew, but during competitions. So again, this just gets everyone in the team involved in the mechanical aspect of robotics. Next, preparing for the future. So next is preparing for failure. So unfortunately, even the best built robots can have failures and parts break, and so it's important to prepare for that. So, as mentioned before, there's many things that can go wrong, and here are just some of the most things that go wrong in my experience as a veteran team. So parts breaking, more specifically 3D printed parts. We used to use just ABA plastic, which is not the strongest, and those can break a lot if you put a lot of pressure. So if you look at the image on the right, that was just a part that snapped. Another thing is parts being made wrong. If you look at the bottom image there, that's a part we attempted to CNC, and if you can see, everything is kind of off. The holes are kind of misaligned. So that's something. And then not having the right parts and not having the right tools, that could really, that's not necessarily something that goes wrong on your end, but it definitely is something that halts progress. And then incorrect measurements, measuring stuff wrong and not finding out you don't fit in the sizing cube, or your part that you designed doesn't fit where you want it to go. So there's a lot of things that can go wrong. And so just how to prepare for that. One of the biggest tips I can give you, if you haven't already been doing this, 3D print extra backup parts. If you can, if you're using 3D printed parts, print more. You never know what part is going to break, and if you're at a competition or you're running matches or you're at an outreach event and that 3D printed part that's controlling your entire output system snaps, you want to be able to replace it. Even if it means you were down for one match because your arm isn't working, you want to be able to get back in, and having the backup parts allows you to be able to do that. And also, if possible, try to make backup parts for high-risk metal parts as well. So, for example, in prior years, we had metal parts that our entire robot was hanging off of, and we made backups of that just in case. We were fortunate that nothing ever happened to it, but we know teams who've had metal parts break. So it's just always important to bring backup parts. And again, similar to that, always bring tools when you're traveling. I'll talk a little bit more about what we bring later on, but bringing tools allows you to ensure that if anything goes wrong, you're able to fix it. And now, in order to ensure that things are made correctly, double check your measurements before beginning to build parts. There's the famous expression, measure twice, cut once. So this just saves time later down the line. And if you have decided to CAD out your robot, that is super helpful for ensuring that everything will fit. So you just have to make sure to check those measurements in CAD. And then again, just take your time when building it, taking an extra minute or two to make sure your part is lined up properly and that all your holes are aligned. It will save time later down the line because you won't have to remake those parts. Now, winning awards and competitions. Mechanical is a crucial part of competitions, as I mentioned earlier, and I'm just going to go into how it can kind of lead to winning competitions and awards. So for winning competitions, you kind of need a good robot. One of the most important parts to having a successful robot is consistency, I've noticed. So consistently scoring low points is often more valuable compared to inconsistent teams who go between scoring high and low amounts of points. So even if your robot isn't able to do some of the high scoring tasks, as long as it is able to consistently score a good amount of points, you're often able to make it as either a final alliance captain or even just be picked on a final alliance team. In prior years, what our team has done is focus solely on ensuring our input was good before even making an output system. This way we could have a strong foundation. And while just having an input system isn't super helpful in scoring a lot of points, in earlier competitions in the season, it was actually really useful just having an input system that worked really well because we were able to consistently score a decent amount of points, and that actually allowed us to be a final alliance captain. So it's really just about consistency. Um, Next, creating a good workspace. As I mentioned earlier, having a good workspace and the proper tools is crucial to building and creating a successful robot. So, as I mentioned earlier, organization is crucial to success. Knowing where everything is helps to speed up the building process because it allows builders to quickly find the tools or any parts that they may need. It also helps get the team into good habits, just, cleaning up after yourself, putting things back where it belongs, really good habits. So, as you can see by the pictures, our team loves labels. We label everything. This just makes everything super easy to find. This way you're not pulling open old jars, like, where's the thing I need? We have just storage cabinets. I think we bought those from Andy Mark, but you could pretty much get them from anywhere, Walmart. And I highly recommend just investing in some kind of storage system. It makes everything super easy. It's easier to find, and labels to label everything in your storage system. You could use label makers, and some of our images, as you can see, we just use like a piece of white gaff tape. So just label and organize makes the process go so much faster because, again, you don't have to spend time looking for parts. And then having necessary equipment. So on top of organization, it's important to have proper tools. And so veteran teams, this is less so for you because you often just acquire tons of tools throughout the years. But for newer teams, it's kind of important to have basic tools. So by designing your robot first in CAD, it's kind of easy to say, okay, so we'll probably need a drill for this, or we'll definitely need to sand down this, so we'll need to buy a hand sander. However, on top of that, there's really no kind of ways to know what tools you need. So it's just about buying a few things as you go. Some helpful tools are just T keys for whatever, for either empirical or metric, depending on what build season you're using. Rubber mallets are always super useful. Hand files, hand drills, nut drivers are all super useful. But again, it's just about building as you go. Because as you'll be working, you'll realize, oh, it would have been easier if we had this. And then so next season, or whenever you get a sponsorship, you could purchase those materials. And next, handling mechanical away from the workshop is really important. So when you go to competitions or outreach events, it's super important that you're also able to maintain your robot. In order to ensure you bring the right stuff with you when you go to an outreach or a competition, our team likes to use a packing list. So this helps us pretty much remember which parts and tools and other equipment we might need. There's been times where we try to bring stuff without this list, and it's just, we always end up forgetting something. And so having a physical list where you could just go down the line and just check stuff off is super helpful. So what we've found to be helpful is just breaking everything up into different categories. So if you look, we have like hardware, tools, electronics, judging materials, pit supplies. So for certain events we're going to, we know what we might need to bring and what we might not need to bring. So for example, if we're going to an outreach event, we don't need to bring the control sheet, so we just will ignore the judging material section. And what we find to be super helpful is we have a printed out and laminated version of this. This way we're able to reuse it, and we just kind of use like an Expo dry erase marker and just check off stuff as we do it. And this way it's just super helpful to ensure that everything we need is going to be with us at some point. And this is having this list online is also super helpful because you'll find that even though you have a list of everything you're supposed to bring, you'll often forget stuff on the list. So as time goes on, you'll add to the list, and just having it written down is super helpful to ensure you don't forget anything. And next, how to stand out. Everyone has, or at least hopefully everyone has some kind of robot, so it's important to make yours try to stand out to be recognized by judges. So one of the most important things is creating a smooth and sleek design. So in the past, our team has used shape optimization, which is basically the removal of non-essential material in order to reduce the weight of the robot. But you don't even need to do that, just making sure that your design is sleek and basically it has planning. It's like, hey, you could clearly tell that this robot was planned ahead of time. One of the best things that I find judges really like is trying to color different parts of your robot to match your team colors. So if you look on the image on the right, we had our robot powder coated. So the sides, which are metal, look blue, which is one of our team colors. Judges really like that because it just stands out, and it shows again how much planning you had and forethought, and it also makes your robot a lot easier to distinguish when it's on the field. Also, if you have a 3D printer that prints in different colors, ours unfortunately only prints in black now, but if it prints in different colors, that's such an easy way to tie in your team's color scheme to your robot. Next, having a design element, something unique that your team is proud of, is super important. There's been many times where judges come up to you either in the pit, or that's one of the questions they'll ask during interviews. What's something on your robot that you're proud of, or what's something on your robot that stands out? And having an answer to this is really important. Even if your robot is kind of quote unquote basic, having something that you're proud of is something judges love to hear, and it really helps you stand out because, oh, our team is really proud of our intake because it's really quick. That's kind of boring. Or our team is really proud of our intake because we actually went through several designs to get to this, and we actually, our last one before this didn't work at all, and so after that we went through and completely redesigned it, and learning from our mistakes we made this design which is far more efficient and scores on average 20 more points than our other one. That stands out a lot more, and even though it's not necessarily unique, it makes your team unique. So just having something that your team can default to as something you're proud of or something you worked hard on is super important, and judges love that. And as I mentioned earlier, making sure your robot is consistent is super important. Even if it's not able to score high amounts of points, as long as it's able to consistently score points, judges love that. Teams that are able to score high amounts of points but don't always work aren't the best. The main goal of engineering solving any problem is being able to do it consistently, so having a consistent robot is super important. And now I'm just going to go over some FAQs, some commonly asked questions that our team has gotten regarding mechanical. So how do you come up with designs? So as I mentioned earlier, brainstorming, we like to just go through and come up with any ideas we might have off the bat, and we like to say that there's no bad ideas. So that's one of the ways we come up with designs. But another way is to just look at what your team has done in the past if you're a veteran team for similar problems, or look at other teams' robots. If you go on YouTube and search like FTC robot reveals, you'll see many different types of robots. And I'm not saying steal their designs, but you can definitely gain inspiration and see, oh, wow, this team used a sweeper intake and it worked really well for a similar challenge. Maybe we should incorporate that into our design. So it's all about just experience, knowing what works, knowing what doesn't, and learning from others, and also testing. You can come up with an amazing design and find out it sucks, but then using that information, you're able to design something that's the complete opposite. It may work perfectly. So it's just something you get better at as your team gets older. Now, what to do if a part or idea doesn't work. So hopefully, if you're testing along the way, it shouldn't be that much of an issue. What you could do is you can either redesign the part entirely, or what our team likes to do is try to figure out ways to make the part work. So if you're redesigning every part that doesn't work, you're gonna spend a lot of time redesigning. So instead, you can often make small adjustments. The biggest thing I can suggest is just testing, figuring out why it doesn't work, and seeing if there's an easy or simple-ish way to make it work without having to redesign the part. So again, it's just all about trial and error. And what's the best way to test ideas? As mentioned again, I feel like a broken record. Testing along the way is super important. So we like to build quick prototypes for any design we're going to do. So even if it's the middle of the season, it's like, oh, we're going to change our input system. We'll build a quick prototype. This way we make sure it works before we're committing to a design. Prototyping and then just seeing if that part would work in that spot is great. So for example, if we're prototyping, let's just say an input system, we'll build the prototype and then we'll just either hook it up to motors just quickly, or we'll even just spin it by hand or whatever. Make sure it's able to actually take in the game elements. And if not, we'll make changes or we just won't go with that design. How do you make / design prototypes? So a lot of times with prototypes, we don't really design beforehand in like a 3D modeling software. What we will do, however, is kind of draw it out on paper or use like a whiteboard, and then we'll kind of come up with basic measurements to ensure that it actually fits, and will be a realistic size. And then we'll just make it using metal, or a lot of times we'll just use channels from like our build kit. So we'll just stick together a few go build it channels and then attach stuff to it to make sure it works. And what are the essential tools for a new team? So this really depends. If you're going with a build kit, such as GoBuilda, you want to grab T keys, which are basically kind of like Allen wrenches or Allen keys, but they have kind of a T-shaped handle at the top, which allows it to be easier to grip, which makes screws easier to turn. But also, if you're on a website like GoBuilda or even Tetrix, it'll give you a list of suggested tools and parts, so I recommend that. Besides like T-keys and Allen wrenches, I recommend like a rubber mallet. I recommend, obviously, like a bandsaw or some kind of saw, a hand drill or drill press, some kind of vice grip. Yeah, I think that's pretty much it. And as you go, you'll see pliers are also really good. You'll see stuff that you need and you'll make changes accordingly. And what's the best piece of advice I have for a new team? It would just be to not give up. There's going to be a lot of stuff. Nothing's going to work right the first time. But the more you try, the more you redo, the more you practice, the more you test, the better your design will get and the better as a team you'll get. So I just keep trying, don't give up. And I know it can be overwhelming, but it's important to break things up into small, easier steps and make it work that way. So that was our presentation on mechanical. I hope it was somewhat helpful. And as I mentioned earlier at the beginning, if you have any questions, you can email outreach@suffernrobotics.org or reach out to us at Suffern Robotics on social media. And you could check out our website for more information about the team. And thank you guys for listening. I hope this was helpful.